Another challenge for the FL is the privacy. So the motivation of doing the failure learning is that, right, we don't want to share the data, right? We say we want to provide some of the privacy insurance, but in reality, there are still ways, we can recover the data, right? Although you do not share the data to the server, but you do share some of the statistical information of the model, right? And then in this case, there are still ways we can leverage the statistical information to recover the data that is reside on the client side, okay? So here is one potential solution that we can using the gradient inversion or data reconstruction based on the gradient to recover the data that is reside on the client side, okay? So here, here basically says, right, we have different local client, right? We share this kind of model updates, right? This is the gradient of the model to the server. And some of the malicious attacker, or if there's a malicious client here, because it has the access to the parameter, right? We have access to the global parameter. We can using that to reconstruct the data, from different clients. So here is their kind of sketch of their method, how we can reconstruct the data based on the gradient information. So the idea is very simple, right? So you have this participant, right? You train the model and you get this loss and you optimize, right? And for some malicious attacker, what they can do is that they can using some of the dummy data, right? Starting from the random noise. And because it has the access to the model updates, right? The weights, it can, basically the idea is trying to match the gradient, right? So you have some random data, but the objective function is trying to match to reduce the discrepancies between the gradient from the random data and the gradient from the true data, okay? So by, reducing this kind of discrepancy, you can gradually, change the input so that once the discrepancy between the gradient has been minimized, and this will reveal the true data, right? So that's the idea. They can doing this kind of data reconstruction based on the gradient information, okay? So here are some of the, basically this is the pseudocode of their method, right? To do this kind of data reconstruction from the gradient. So I'm not going to go to the details, but this key step, as I mentioned before, right? Basically just trying to minimize the discrepancy between the gradient from the dummy data and the gradient of the true data, right? So using this as objective, you can change the input to recover the original data and the label information. So you can think about this like the, as we talk about these adversarial attack, right? So we do not change the model, right? When we do the optimization, right? The model parameter are fixed, right? We just change the input, right? To change the input, what kind of noise we want to add so that the prediction will be totally different. So in this case, we also change the input, right? Starting from the noise and gradually by minimize the gradient discrepancy, and the input can gradually reveal, right, what is the true data reside on the local client. So by doing this kind of reconstruction using the gradient, they show if you do, at different iterations, right, they are able to recover the data actually very well, right? Based on this example here, this is doing the digit classification. This is the ground truth, right? They are able to uncover, this is the digit of 5. And this is also a face image, right? And these are the digit and this is a tree. So these are very good examples to show that using this method, they are able to recover the original data from the gradient information. So this is not good for failure learning, right? If some malicious attacker, as a, participate in the training then they can using this kind of gradient inversion attack to reconstruct the data, right? So in this case, there's no guarantee, there's no data leakage in the federated learning, right? So we still need some, privacy preserving strategies to ensure, the data is secure. So there's a couple of strategies we can do for privacy preserving. One is we can do this homomorphic encryption. So this is kind of like a standard approach in the data encryption domain, right? We can do this homomorphic encryption to secure the learning process by computing on the encrypted data, right? So because the data is encrypted, even though you can do the encryption, you are still not able to uncover what is the original data. And another one is we can do this secure multi-party computation. So this, again, is a commonly used strategy to prevent privacy disclosure. This has been used in the federated learning setting as well. And another one is the differential privacy. Okay, so this is one very popular method that it has been used in the federated learning to enforce the privacy preserving aspect. So basically, when we have this model updates, right? Instead of sending the true gradient or the model update to the server, we can add in some of the noise or perturbation to those gradients, right? And in this case, we kind of destroy some of the true information in the model updates, right? So this is another way we can improve the privacy preserving. One downside for the differential privacy in federated learning is they will also affect the performance, right? Because we injecting additional noise to the statistical information. So this will also make the performance suffer. So this is these are the common strategies. So for the privacy preserving in federated learning. Okay. Any questions before I continue? Okay, there's many applications for the federated learning. So predominantly there's a couple of applications here. One is the smartphones, right? So we use smartphones every day. So we have a lot of data has been generated 24/7, right? And we also using a lot of apps on our smartphone. Right. So in this case, we want to leverage these big data, right, to train a very robust model, but without sharing the personal data on our phones, right? So in this case, federated learning can be a very effective method to collaborate to train a machine learning model that can work well for everyone, for every user. And specifically, personalized FL can be very useful, right? Because different user has different needs and have their different data distribution. If we can customize or tailor the federated learning model for different individual users, and the performance can be improved as compared to if you're just trying to fit one federated learning global model for every users. Another application is for organization, right? So for like the hospitals and maybe some other institutions, organizations, they don't have a lot of data, and they do want to collaborating with each other so that their model can be improved over time, right? So they can also using the federated learning to do this cross silo federated training so that their model can be improved. And this is particularly true for the Medicare or healthcare applications, right? Hospitals can do federated learning to improve their machine learning model for some of the healthcare or medical applications. And Internet of Things, right? We have a lot of IoT devices. They all have some AI capabilities, right? We can do some, machine learning training on the edge, right? So these wearable devices, smart devices that can be placed at home, right? Sensors, they all generate the data, and they all can perform some of the machine learning training on those devices. So we can consider federated learning, and and to learn a better model, to adapt, right? In particular, we can using feather learning to adapt the model over time, right? So that's the IoT application scenario. And let's look at some of the cases specifically for medical imaging. So one case is the predicting the oxygen requirements of patients with COVID-19. So in this application, they use data from 20 institutes across the globe to train a FL model called exam. So electronic medical record, chest X-ray AI model. So they're using this model to predict the future oxygen requirement for a patient, okay, with COVID symptoms, okay. So basically they want to, with the patient with COVID-19 symptoms in the initial stage, right? So we don't know much about COVID-19. So there's a lot of patients coming and we want to maybe set a priority, right? And, which patient should be given the priority to have this kind of oxygen and to have the treatment first. And this study was led by the Mass General and NVIDIA. So they're using the feather learning to train their AI model to do this kind of oxygen requirement prediction. And this is their result. They compare their feather learning learned model with the machine learning model trained with their local data. Okay, so the blue color indicating the model trained locally, only using the data residing in their each individual hospital. Okay, and this green one, which is the feather learning model, right, which is using the feather learning to aggregate the knowledge from different hospitals. And based on this figure, it is very clear, right? So using the feather learning can improve the performance across different clients, right? So on average, they are able to improve into 16% improvement in terms of the oxygen prediction. And the second case is using the feather learning to detect COVID-19 lung abnormalities in CT. So in their study, they recruited 132 patients from 7 multinational centers and 3 from Hong Kong for training and testing, and the other 4 as their external evaluation to test if their model is able to generalize well. Okay, so if you look at the figure here, right, so they're using data that has been collected at 3 hospital, they call this internal set, right? Set 1, 2, and 3. They train the feather learning model on these 3 set of data and in the feather learning way. And then when we're doing the testing and they deploy this trained model with data generated from the other 4 external set, right? These data are generated in mainland China and also data from Germany. So they're using this kind of separate set to validate if the model is able to generalize well for this COVID-19 lung abnormal detection in CT images. Okay. So there's a lot of industries adopting feather learning, especially in the medical imaging sector, right? So a lot of hospitals and medical schools at the universities, they're using feather learning to develop machine learning models for medical image analysis. And also for pharmacies, right, they can using feather learning to do some drug discovery, right? So these are some of the companies they are doing using the feather learning, adopt feather learning in their applications. So there's not necessary for medical or healthcare, right? So there's also other stakeholders, healthcare stakeholder can benefit from AI, but using the centralized training, right? So the data privacy is one primary concern. But if we're using the feather learning strategy, this can increase the value of AI for different healthcare stakeholders, right? And also, especially for manufacturers, right? Maybe they have to constantly improve their machine learning system, right, to meet different standards or to meet different requirements, because these standard requirements are change or evolve over time, right? They have to constantly improve their machine learning model, and federated learning provide an effective way to kind of collaboratively learn the knowledge over the time without sharing the private or privacy sensitive data. Okay. Finally, I want to also mention a couple of workshops and conference that is specifically dedicated for federated learning. So as you can see, a lot of major machine learning or vision conference, they all have workshops for federated learning, right? This NeurIPS and ICML. There's also Triple AI and IJCI. They all, like AI or machine learning conference, they have these workshops dedicated for federated learning. I also organize these federated learning for computer vision. So this year, next year, CVPR 2023, that's the second edition. So if you are also interested in federated learning and you happen to do some computer vision or medical image computing task, you are welcome to look at this workshop or maybe submit your contribution. Okay. Okay, here are just some couple of resources for you to learn more about federated learning.